Yesterday, we had a lesson about how to get the equation of a cubic function if I give you 2 or 3 x-intercept points. Then you use this formula to get your equation. Now today, I'm going to help you to find the equation if I give you the first derivative. How do you get the equation of a cubic function if you only have the first derivative? That is example number 4, page 46. So they tell you y equals the first derivative of x. They give you the equation of fx. And from the picture, we can deduct that the cubic function is positive because the parabola is positive. Okay. What we can do here is first find the equation of the first derivative. So find the equation of the parabola. You already know how to do that. You use this standard form and you just substitute what in there. The x values. So it will be 1 and 2. Now, I also have another point. It is the y-intercept at 12. So I can substitute that coordinate. X is 0, y is 12, into the x and the y variables. Y is 12 equals a. X is 0. 0 minus 1 is -1. 0 minus 2 is -2. If you multiply that, you get 2a equals 12. Get a alone, so I divide by 2. A equals 6. Now you substitute this a back into the parabola of that format. But this y is actually f accent x. So we can say f accent x equals 6 x minus 1 x minus 2. Everybody with me so far?
Yes.
Right. The 6 I'm going to keep a little bit at the outside. Multiply these two brackets, then you get x squared minus 3x plus 2. Now multiply the 6 into the bracket, then you get 6x squared minus 18x plus 12. And that is what they asked. They wanted the first derivatives equation. Any questions so far? Now the follow-up question, they want to know, now that you have the first derivative, find f. Now at university in the first year level, we call this integration. So we have to integrate this to get that. But it's not in the grade 12 syllabus. So now I'm going to teach you a trick. Not by integrating, but to get fx if you have the first derivative. Right. There's my fx. They gave it to me in the question. So I'm going to differentiate that first. Then you get 3ax squared plus 2bx plus c. Is that correct? But I also have a real f accent x, a real first derivative. So I'm going to write this one just below the one that I did just now. F accent x equals 6x squared minus 18x plus 12. These two must be the same because it's the same function. Do you agree? Therefore, the coefficients must be the same. Oops, doing that song. So 3a is equal to 6 and 2b is equal to negative 18 and c is equal to 12. Now we just need to work out what a is. A is 6 divided by 3 is 2. B is negative 18 divided by 2 is negative 9. And we have c. Now I have a, b, and c, so I can substitute it back into the formula that they gave us. Therefore, fx will be a is 2x to the power of 3 minus 9x squared plus 12x. There's your answer. Sometimes you get a D. Then if you differentiate the original one, you'll also get a term there. No, you won't get a term there because D doesn't have an X. No, no. You won't have a D. This will be if you differentiate the original one and you differentiated the deduct it from the sketch, you'll get A, B, and C, and for your now they ask us, give me the x values of all the stationary points. Of this at the end. There's my sketch. What are the stationary points? Turning points. But they are talking about the turning points of the cubic function. Now, how can I draw the cubic function? I know it's a positive one because the parabola is positive. So let's draw a positive cubic function. What do I know about the x values of the turning points?
The x-intercept of the parabola.
Yes. So the x-intercept of the x value of that turning point will be 1. And the x value of that turning point will be 2. So what are the x values of the stationary points? The same. Therefore, x will be 1 or x will be 2.
Shouldn't you say and?
Yeah. And?
Shouldn't you say and, not or?
Yeah, you can say and.
No, I'm asking, should you move like? Because this one, there's no, it's not or.
Yeah, it's actually an and. It's 2. Yeah, it should be an and. Yeah. Okay, there was just another errata in. Where was that? Here. I'm not sure whether yours is also a minus. There must be an equal sign in your notes, not a minus. At number B. Now, at number D, I want to know where is f, the cubic function, increasing and where is f decreasing. So increasing will be positive gradient. Those two. It will be smaller than x, than 1, and larger than 2. So x is smaller than 1, or x is larger than 2. Decreasing will be, where is it going down? In this part it's going down. Yeah, the notes are better. So where is it decreasing? It's between 1 and 2, smaller, smaller. Just correct it on your notes. At D. And that's the lesson for today. So, when I give you the first derivative sketch, you must get the first derivative of the original one, and you work out from the sketch the first derivative's equation.
Now, can't you work it out like without having to do that method? Like, can't you just know that?
By integrating.
Yeah, I don't know
if you can do it correctly.
Like just working back and
yeah. If you can do it correctly, you'll get your marks.
But then you say it's never gonna be a D because with the D, are you gonna miss it?
Then you just write plus D.
But is there ever gonna be one way to work back and there's a D?
No.
Not if we integrate, I'm going to use marks for when you show that if x and x is supposed to be this and x and x is the first two marks. If we just know that, oh.
If at the end you get the correct equation, you have to get all the marks. Except if I tell you, show that the first derivative is equal to the first derivative of the parabola, and then deduct A, B, C, and D. Then you must do it like this. But if they don't ask you a specific method, and you get the same answer, or the correct answer, you get all the marks.
Also, if you just write the answer, you get 6 marks.
If the answer is correct, yes. More questions? Okay. Your homework for tomorrow is exercise 11, number 5 and 6. The same exercise that we did yesterday, but now it's number 5 and 6. But at number 5, they didn't put in a y-intercept. The y-intercept must be 15 at number 5.